In the last video, we looked at finding a term or terms in an arithmetic sequence. An arithmetic sequence, as we saw, has a common difference. So our sequence might be going up by 2 each time. It might be going down by 1 each time. It might be going down by 10 each time. Each arithmetic sequence will have a common difference. We saw the nth term was given as a sub n is equal to a sub 1 plus n minus 1d. We're now going to move on and look at arithmetic series. A series is simply the summation of a sequence. So if we wrote down an arithmetic sequence, 1, 4, 7, 10, 13 and so on and so forth, we could write the series if we liked as 1 plus 4 plus 7 plus 10 plus 13 and so on and so forth. What we're going to do is look at the sum of n terms. The sum of n terms of an arithmetic series is given in two different forms. S of n is equal to n over 2, 2a plus n minus 1 multiplied by d, or we could write this now as the sum of n terms is n over 2, and then we'll have a plus l. Let's just consider what each of these is. This is S sub n, so we introduced the idea of this subscript notation in the last video. This is just telling me I'm summing n terms. So if I wanted to sum the first 3 terms of this particular or this series here, then we would have S sub 3, and I'd end up just adding these to get 12. N is the number of terms. A is the first term, D is the common difference. With this one here, the sum of n terms is n over 2 a plus l, where a is the first term and l is the last term. L is essentially a sub n, and we can say that L is going to be a plus n minus 1d. This is the nth term. So if you have now the last term and the first term, we can go ahead and use this particular formula. What we're going to do is spend some time deriving this formula right here. So what I'm going to do now is sum n terms manually. So if I take the first term, we know that's a. We saw in the last video the second term is a plus 1 lot of d. We know that the next term is going to be a plus 2 lots of d. Then what we're going to do is keep adding terms, a plus 3 lots of d. Then we will go right up plus dot dot dot. We will have a plus n minus 2 lots of d. And then our nth term, which is our last term, which is going to be a plus n minus 1d. And that gives us now the nth term. What I'm going to do is just rewrite this, and I'm going to derive this formula that we'll be expected to use. And you may be expected to derive it. If I rewrite the sum of n terms, I'm going to write this backwards. So what I'm going to have is a plus n minus 1 lots of d. Then I'm going to have plus a plus n minus 2 lots of the common difference, then plus dot 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 a plus 3d, then I'll have now plus a plus 2d plus a plus d, and then finally the first term plus a. What I'm going to do is add these two together. So on the left hand side, if I add S of n and S of n, the sum of n terms and the sum of n terms, I'll get 2 lots of the sum of n terms. Let's consider now adding these, and what I'll do, I'll highlight what I'm going to add. I'm going to add now the term here with the term here. If we do that, we're going to get a plus a, which is going to give me 2a plus n minus 1d. So what we'll have then, adding these ones, we'll have 2a plus n minus 1 multiplied by d. Remember, I'm summing n terms right here. So manually, I've summed right up to the nth term. Now, let's take the next one. Let's take this one right here, a plus d. So what I'm going to do, I'm going to add a plus d to now this quantity right here, which is a plus n minus 2d. Now if we look at what we're going to get here, we've got n minus 2d, but remember we've got an additional d here. So if you want to, you can expand that out and collect it all back up, but essentially what we're going to have here is 2a plus n minus 1 lots of d. And we're going to keep getting this such that we're going to have 2 lots of the S of n is going to be equal to n lots now of this quantity right here. Remember, the more I add, that is all going to give us the same expression. We can see right here, if I add these two, we're going to get exactly the same. So what we end up with now is 2a plus n minus 1 multiplied by d. So all I'm left to do now is just divide both sides by 2. So we can say the sum of n terms is n over 2, 2a plus n minus 1d. Okay, so that's now derived it. So if you were asked to derive that in an exam question or show that or prove, then we've done that by simply now writing this out forwards and backwards and then adding the two together, and we've seen that the sum of n terms can be written such that we have n over 2, 2a plus n minus 1d. So that's how you derive formula. Let's now look at this right here. The sum of n terms is n over 2a plus l. So what I'm going to just do is write this out. The sum of n terms is n over 2. Then what we're going to have is a plus n minus 1 multiplied by d. If we consider this part right here, what we've got, all I've done is split this up. So this part I've got 2a plus n minus 1d. So I've written that as a plus n minus 1d. Now, what do we know about a plus n minus 1d? Well, that gives us the nth term, which we've got up here, which is the last term. So all we need to do is put that L is a plus n minus 1d in here, and we can see, therefore, we can use the sum of n terms is n over 2, a plus L. So depending on the information we've got, depends on which one of these we would use. So that's a nice way to now show the formula now for the sum of n terms of an arithmetic series. We will be given enough information to either find the sum, the number, the first term, or the common difference. Okay, let's get some basic practice. What we're going to do is sum the first 10 terms. So let's just write this out. Sum first 10 terms. I'm going to write out now some arithmetic series, and we're going to go ahead and do it. So let's just take the one that we had. 4 plus 7 plus 10 plus 13, and so on and so forth. When you're doing this particular topic, in the last one we looked at A, N and D. What I suggest is A, N, D, S and L. A is the first term, N is the number of terms, D is the common difference, S is the sum, and L is the last term. So sometimes one will lend itself to the other. All we need to do is essentially, though, collect 3 pieces of information. So let's have a look at this one then. What's the first term? The first term is 4, that's A. The number of terms we're after is 10. The common difference is going to be 3. Therefore, we can find the sum right here. So using the first one, the sum of n terms is n over 2. We've got 2a plus n minus 1 multiplied by d. So we're just plugging numbers in. The sum of 10 terms will be 10 over 2. So I've just put n is 10. 2 lots of a, which is 2 lots of 4, plus n minus 1, so it's 10 minus 1, multiplied by the common difference. So let's do a bit of tidying up. The sum of 10 terms is going to be 5. Then we're going to have 8, and then that's going to give me plus 27. So what do we end up with? The sum of 10 terms is going to be 5 times by 35, and that's going to give us now 175. So these are generally non-calculator. You certainly don't need to show all that working, but some appreciation of applying the formula and you will find your value. So I've put those numbers in and we've gone from there. Okay, let's sum first 10 terms. So let's do sum of 10 terms, first 10 terms, and we'll take another arithmetic. So let's go for another one. Let's write a sequence out. Let's write minus 8, no, let's go minus 6. In fact, let's go minus 6, minus 8, minus 10, minus 12, and so on and so forth. So we can see now that this is arithmetic. We've got a common difference. It's going down by 2. So let's write some numbers. A, N, D, S, and L. So A, let's take our first term. That'll be minus 6. We're after the summation of the first 10 terms. Common difference, be careful here. Students often write 2. Remember, it's minus 2. So from that, we've got now enough information to use now the sum of n terms is n over 2, 2a plus n minus 1 multiplied by d. So the sum of 10 terms is going to be 10 over 2. Then 2 lots of a, and I'll just sub this straight in. That's going to be minus 12, plus now 9 lots of minus 2. So what's that going to give us? That's going to give us now the sum of 10 terms is 5 lots now of minus, what's that going to be? Minus 30. So we can say the sum of 10 terms is going to be minus 150. And again, non-calculator question, fairly straightforward. The vast majority of examples we do in this video are going to be very basic. In the next couple of videos we're going to look at building on this and look at some wordy questions, but essentially they all fall into the same bracket. We take the values that we're given and we find an unknown. So whether that's for sum, whether it's for number of terms, whether it's the first term or the common difference. Okay, let's flip this around and let's now look at finding the number of terms. So this time let's find the number of terms. So find number of terms in a series. What we'll be told is the following. Let's say we're told the first now is going to be equal to minus 12. We'll be told the last is going to be equal to, let's go for 40, and let's say that the sum, let's do a sum of now 196. So if we collect the information A, N, D, S and L, what we want to do is find the number of terms. Now just say that that's going to be N. We've got the first is going to be minus 12. We've got the last this time, which is 40. So which one can we use? If we look at this now, we've got the sum, and that gives us now the ability to find N. We can say the sum of N terms is N over 2, and then we'll have A plus L, where A is the first term and L is the last term. So what we've got here then, the sum is going to be 196. So 196 will be equal to N over 2, and then we're going to have A, which is going to be minus 12, plus now L. L is going to be 40. So let's go ahead and rewrite this. 196 is equal to N over 2, and then we're going to have 28. So 196 over 14 is going to be equal to N. So that's going to give us 14. 14 squared is 196. So we can see that the number of terms in that one is 14. All we've done is just gone ahead now and simply found that. We might be asked to find the difference, which really shouldn't be a problem. We can use any particular of our formula to do this. So if we wanted to do that, we could go ahead, and we know that there are 14 terms in here. So let's just now put in the following. Let's put in some information. I'm just thinking out loud here. A, N, D, S and L. So let's do that. Now, if we wanted to find now, let's say we wanted to find the common difference, let's look at the information we've got. We've got the first term is going to be minus 12. We've got now the number of terms, so we're after that one, so we've got 14. We know now from here that we're after the common difference, which is going to be D. And what other information have we got? Well, we know that the last term is going to end up now being 40. So we can just sub this in. So if we think A sub N is equal to A plus N minus 1 D, I'm just thinking out loud as I do this, just to plug in the values we got. So 40 is going to be equal to the first term, which is minus 12, plus now 13 lots of the difference. So that's going to give me 52 is equal to 13D. So D is going to be 52 over 13, which is going to be 4. So we found the common difference as well. I'm kind of thinking there might even be a quicker way of doing that. But as you can see, we can be quite flexible. Once we've got some values, we can just sub it into the formulae that we know. So if you do find a slicker way of doing that, I'm sure that there is one. Just looking at it right here, you can probably find it a nice way. But we can just jump between it now. Different skills that we've got, understanding that these arithmetic sequence series are simply going up by a fixed amount and then finding other particular values in there. The one thing I would say is please don't try and do this manually each time. You'll be penalised in terms of the marking in an exam, and you will come unstuck, because sometimes, especially with the practical applications, when you've got some nasty word problems that involve finances, for example, or the age of something, it really will not be an option. So just apply the formula and then put the numbers in to find the unknowns. Okay, what we're now going to do is move on to sigma notation. Sigma is Greek to sum. So let's look at an example. What we might have now is the sum from r equals 1 to 6 of 3r plus 2. If we look at this, this is arithmetic. Let's just consider now generating the first few terms. If we took r to be 1, we would have now the first term, which would be 5. If we now took r to be equal to 2, we would have 3 times by 2, which is 6, plus 2, which is going to be 8. Then if we took it to be 3, we'd have 11. and then if we took it to be 4, we would just simply be adding now 3 each time. So all we're doing is adding now. Now I'm going to sum the first 6 terms, and you can see that I'm going to do this manually. Okay, but let's just go for this anyway. So the next one is going to be what we're going to do. We're going to add 3, and we're going to add 3. Okay, so if I wanted to sum the first 6 terms, I could do that manually, and quite clearly adding those is not going to be a massive issue. But again, we might not have something as nice. Let's just dissect this. This now is telling me to sum from r equals 1 to r is equal to 6. So we evaluate 1, 2, 3, 4, 5 and 6. Let's look at this now as an arithmetic series. A, N, D, S and L. So what's A? A is our first term. Well, that's when r is equal to 1, so we know that that's 5. If we look now at n, n is the number, well that's going to be 6. Now be careful, it's not always going to be 6. So for example, if that was starting at 4, quite clearly there would be 6 terms. If we look at the common difference is this value right here, so that's going to be 3. So if we wanted now to find the sum of n terms, we could actually use this. So for example, if this wasn't as nice, we could simply plug them in. Alternatively, what we could do is just take the last term. If we consider now the last term is going to be 3 times 6 plus 2, which is 20, which we've seen. So we can say the sum of n terms is n over 2, the first plus the last. So we can say now the sum of 6 terms is going to be 6 over 2, then we're going to have 5 plus now the 20. So if we do 5 plus 20, what are we going to end up with? 25. 25 times by 3, the sum of 6 terms is going to be 75. Of course, you could do that manually. That's going to give you 37, 51, and then 62, then 70 and 75. But clearly, that's only because they're nice, easy numbers to work with. So all we do is essentially, let's just read in this notation. Let's do another one. Let's do another one using sigma notation. So let's say we're now summing. Let's sum from r is equal to 3, and then we'll go to 20. And let's say now we've got 4r minus 2. So again, this is going to be arithmetic. We can spot that as an arithmetic series or sequence. And just be a little careful. We've got 3 in the bottom. Now, if we think about it, the terms that we're missing, we're not going to sum from 1 to 20. We're actually only going to sum 18 terms because we're not summing 1 and 2. Now, there are different ways that you could do this. What you could do is collect information A, N, D, S and L. So if we look at the first term, that's going to give me now 3 times by 4 minus 2, which is going to be 10. The number of terms, be very careful. A massive error would be to write 20. We can see that we're missing 1 and 2, so it's going to be 18. The common difference is going to be 4. We've seen that from there. And if we think about it, we can get the last term. The last term is going to be 4 times by 20, and then subtract 2, so 78. So this one we could use, sum of n terms is n over 2, and then a plus l. So the sum now of 18 terms is going to be 18 over 2, so 18 over 2, then we're going to have 10 plus now the 78. So what's that going to give me? That's going to give me 9 times by 88. So the sum of 18 terms is going to be 9 times by 88. Let's do some quick maths. What's that going to be? 792? 792. So that's doing it that way. That's just taking some values. But don't be scared of this. Now, if you really wanted, you could take this from r equals 1 to 20 and subtract r is equal to 1 to 2 away. That's an option for you. I really don't think it's really, so we could write, now we could do from 1 to 20, and you'll see that with different series this is quite handy, but essentially what we would do is this. We would evaluate those two and subtract them away. I really don't think it's massively necessary. Alternatively, we could have gone the other way, and we could have, with this one, we could have said the sum of n terms is n over 2, and then 2a plus n minus 1d, and then just subbed in the values. So the sum now of 18 terms is 18 over 2. We're going to have 2a. Well, that's going to give me 20. And then we're going to have plus now 17 lots of the difference, which is 17 times by 4. and then we can see now that it's going to give me exactly what are we going to have on there. Let's do that. So the sum of 18 terms is going to be 9, and then we're going to have, what's that going to give me? 20 plus 68, which again gives me exactly the same thing. So it's just using a different formula based on the information that you collected. So this is sigma notation, and we will see this when we come to sum these series. It's just Greek, it just means sum. You give them the values you sum it from, and just make sure that you're comfortable of how many terms that you're summing. Okay, let's just finish with one more. Let's do something slightly different. Let's do a show that question. Let's do show that the sum. So we'll take the sum from r equals 1. So r is equal to 1 to n. Now we might see this just now as the sum, and we might have 1 and n. So don't be alarmed if you don't have an r there. And let's say we've got 2r minus 5, and we want to show that this is n and then n minus 4. So what we've got then is the sum from r equals 1 to n of 2r minus 5, and we need to show that is equal to n multiplied by n minus 4. So let's go ahead and collect some information. A, n, d, s, and l. So what's our first term? Well, our first term, if we sub in r is equal to 1, 2 lots of 1 minus 5 is going to give me minus 3. Okay, the number of terms, well, that's going to be n. That's how many we're summing. We're going from 1 to n. Then if we consider now what the last term is going to be, if we sub in n, 2n minus 5. So let's go ahead and do that. We know that the sum of n terms is n over 2, the first plus the last. And we can write this now as the sum of n terms. And if we just consider what we're going to have here is n over 2, and then we're going to have a, which is minus 3 plus 2n minus 5. So let's do some rearranging. The sum of n terms is n over 2, 2n minus 8, and then all we do is just divide through. So the sum of n terms is going to be n, and even if you want to show at this stage, if you really want to, you can take out the 2 and then write n minus 4. If you really want to show the examiner, I don't think you'd need to. I think they'd be fairly happy with that. n minus 4. So all we've done is simply gone ahead and applied that particular formula. So we're just summing now these terms like so. So that's a nice little question. You're plugging in numbers, and you're simply now expressing this now as the sum of n terms as n multiplied by n minus 4. So there's a brief introduction to arithmetic series. A series is simply the summation of a sequence, and we can use two different formulae. We can use now the sum of n terms is n over 2, 2a plus n minus 1d, or the sum of n terms is n over 2a plus l, where a is the first term, l is the last term. You can derive those formulae by simply rewriting the two sums of n terms together, adding the two, and then dividing through. In later videos, we're going to do some word-based problems and some exam-style questions. Hopefully now you've got all of the skills, though, to tackle those.